Okay. Recording. Okay, so topic, arcs and chords. So in a circle, two minor arcs. So here are two minor arcs. Here's one, and here's another. Two minor arcs are congruent, comma, corresponding chords are congruent. So this is saying if I know that this arc is congruent with this arc, then this chord must be congruent with this chord. It's corresponding to that arc. Okay, got it? And you could also say, if two chords are congruent, then their corresponding minor arcs are congruent. So it goes both ways. Questions on that? If you know the chords are congruent, then their arcs are congruent. If you know their arcs are congruent, then their chords are congruent. You know what? In the other class, I looked at something different. So hold on. Okay, so this is your first example. A regular hexagon is drawn in a circle as part of a logo for an advertisement. If opposite vertices are connected by line segment, so let's stop right there. If opposite, lose my voice. If opposite vertices, so this is inscribed inside of this circle, right? This regular hexagon. It says that if opposite vertices are connected, so that's saying this one's connected with this one, with this one, with this one, okay? If opposite vertices are connected by line segments, what is the measure of angle P in degree? So I'm looking for angle P. So this goes along with the fact that I know that every single one of these chords are congruent. How do I know that? Okay, that's by looking at the paper plate example that I just showed you. If I were to fold each one of these, they would all be the same. But without doing that, what in this sentence up here tells me that they're all congruent, each side of this pentagon? Pedro. A regular hexagon means that each side is congruent, and that means each angle is congruent too. Okay, so from that first theorem that we just talked about, if I know that this segment is congruent with this segment, is congruent with this segment, right, all these are congruent, then all of the arcs are also congruent. And I learned yesterday that if the measure of the arc is congruent to, yes? The measure of what? I'm not asking for the answer. I'm asking for if the measure of the arc is congruent to which angle? What do we call it? The central angle. So that means each one of these angles are congruent. Good, you guys are doing good. So, Devin, how did you come up with your answer? Oh, so you looked at it as a semicircle. Or you could say 360, because every circle has 360, divided by 6 angles equals 60 degrees. But I'm tying it to the definition that I just gave you, or the theorem that I just gave you. Okay. Alrighty, in a circle, let me let you write this one down. And we're going to use this circle for 2 of the examples that we're going to do. Okay, so this is saying in a circle, if a diameter or radius is perpendicular to a chord, then it bisects the chord and its arc. So that's basically saying if this right here bisects, or I'm sorry, it's perpendicular, since it's inside of a circle, then automatically we can say that this is congruent with this, right? And therefore, these are also congruent. A radius wouldn't. A radius would always be coming down. Yes. Yes. Exactly. Okay, so let's use this for the next example. Same circle, okay? Circle W has a radius of 10. So I have a radius here of 10. Radius WL is perpendicular, so this is perpendicular to chord HK. So that right away tells me that these are congruent, which is 16 centimeters long. So if this whole thing is 16, then what's one of them? 8. If the measure of HL is about 53, so this right here, HL, is about 53, find MK. So we're looking for MK. Okay, so with this piece of information, I also know that this arc is also 53. So in order to find this arc, what could I do? Easier. 180 minus 53. And this is about 53, so it would be about 127. This is about 127. So let's try another one. Circle W has a radius of 10. Radius WL is perpendicular to chord HK, which is 16 meters long. Same thing. Find JL. So now we're trying to find this. And I already know that this is 8, and this whole thing is 10. Right? I see a right triangle here. Anybody have any ideas?
I have a question.
Yes.
So that means the right angle is the lowest. No, the lowest. That right there.
Yes, that right here.
Like right below where the right angle is, does that mean the line is on my angle right there is the 90 degrees too?
This angle is 90, this angle is 90. They're all 90 right here, which makes 360. It's so obvious it's not. They told us that the radius is 10. Can't I draw another radius? Right? Why not? I can draw radii all over the place if I wanted to. It doesn't matter where I draw it. It's always going to be a radius of 10. 7. I'm sorry? It says 10. So I'm going to, just because it's easier to see, I'm going to recreate this triangle so I can make sense of it separately from my circle. And I'm going to say, well, I know that it's a 90-degree right triangle. I know that the hypotenuse is 10. I know one of the legs is 8. If you know your Pythagorean triples, this is a 6, 8, 10 triangle. But if you didn't know that, you should know 3, 4, 5, 6, 8, 10, 9, 12, 15. Those should just roll off of your tongue. That's okay. All right, so I know 9, 12, 15. I know that the area of this side is 100. I know the area of this side is 64. So would I add or would I subtract to find the area of this side? I would subtract. So that's why I draw it out, guys. You could use the formula, but when you draw it, it's plain as day whether you're subtracting or adding, right? So 100 minus 64 equals 36. So I know that x equals the square root of 36, which is 6. But I'm not done. I just found this side, correct? So in order to find JL, I need to subtract 6 from 10, which is 4. So my answer is 4. Okay, so this is stating that in a circle or in congruent circles, two chords are congruent. So this chord, if I say that this chord is congruent with this chord, if and only if they are equidistant from the center. So that means this must be equidistant to this. Correct? So you can either say, okay, that chord is congruent with that, therefore I know that this is congruent with this, or if this is congruent with this, then I know that this chord is congruent with that chord. That's what that's saying. So let's apply that with this next problem. Chords EF and GH are equidistant from the center, so that just told me they're congruent. If the radius of P is 15, so radius of P is 15, I don't have a radius. I'm going to give it away right now. Where should I draw my radius? From the middle, where? Here? Here? Oops. To the H? Why? Because it makes a triangle and it's probably going to help me solve this problem right now, right? So, let's keep reading. So, if the radius of P is 15, this is 15, and EF is 24, here's EF. If EF is 24, guys, if EF is 24, isn't GH also 24? If GH is 24 and this is perpendicular, what does that mean that RH is? 12. So if I were to redraw this triangle, it would be 12, 15, what would this be? 9, if you know your triangles. But let's say we don't. Let's say we don't. So this is what? 225. Let me erase this and make this. It's going by threes, exactly. So this is 12. This is 15. Just changing my color. This is 225. Down here is 144. That means that this square must be, I'm guessing, 81 is the answer to this. So the square root of 81 is 9. So this side is 9. Did we answer what we were looking for? If this is 9, did we answer it? That's your last. You have to go back and make sure, did you answer what the question was asking you? Because there's several steps to these problems, right? So it says, find PR and RH. I found RH, I found PR, I'm done. Good job, guys.